Go to universeunboxed.com to learn more about SciShow Science Kits, and stick around to the end of the episode to hear more about this exciting new SciShow project. We're told that every snowflake is unique, that every single one grows slightly differently to produce one-of-a-kind, six-pointed forms. But these are crystals growing in 3D space. It seems like they should be able to grow in any direction. So actually, when you think about it, why are they always flat hexagons? Why are snowflakes basically 2D? It all comes down to how ice crystals form on the molecular level. The most important condition for determining what shape a snowflake will take is temperature. Different temperatures generally correspond to different shapes. Between about -10 and -22 degrees Celsius, you're most likely to see that feathery six-pointed shape known as a dendrite. But snowflakes aren't always flat. Depending on atmospheric conditions like temperature and humidity, they can form columns, rosettes, needles, or any number of shapes. Between -3 and -10 degrees, they might form hollow columns or narrow needles. But the most basic snowflake structure, found at a wide range of temperatures, is a flat hexagonal plate rather than a flowery dendrite. We don't know exactly why temperature has such a drastic effect on the shapes of tiny water crystals, but we do know that they're relatively 2D. So why is that? The six-sided symmetry of those simple plates is a direct consequence of the structure, the molecular structure of water. Water molecules have what chemists call a bent geometry because it looks like it's been bent in half. You've seen pictures. Water is also polar, meaning that one end of that bent molecule, the oxygen, has a slight negative charge to it, while the two hydrogens are slightly positive. This means that when water molecules come together to form a solid, they will line up so as to match positive and negative charges, oxygen to hydrogen, which naturally lends itself to a hexagonal shape as all the bonds align. This feature of crystal growth, where the availability of chemical bonds dictates the larger structure, is known as faceting. Depending on the conditions, water molecules might grab the edge of the hexagon more easily, making a thin plate, or the face, meaning it will grow into a column. This odd effect is known as sharpening. Now, if that were the whole story, all snowflakes would have a hexagonal structure. But when conditions are right, those hexagons can start to branch out. This is where our other most important condition comes in: humidity. As a snowflake grows, the water around it is incorporated into the crystal, meaning in that tiny environment, there's less water, and water molecules have to travel a little farther to join the snowflake. But near the edges, water molecules don't have to travel as far, so they join the edges more easily and quickly, and sharpening, once again, leads to smaller structures closer to the edges of the snowflake. As the crystal grows larger, it also starts to grow faster as those molecules attach to the edges. And whenever conditions make it possible for a crystal to grow faster on its edges than its faces, the edges can get really elaborate, producing those dendrite structures. The conditions have to be just right for this to happen, but it's not just water that does it. Even table salt can form dendrites under the right circumstances. So we're lucky that the conditions are so often just right when it snows. It means that we get to enjoy the beautiful array of shapes we picture in a snowflake. Although other crystal structures, small ice columns falling from the sky, that would also be pretty cool. Before you go, we at SciShow are super excited to bring you Universe Unboxed, our very own line of science experiment kits for kids elementary school aged and older. They're full of experiments that can teach you basic concepts, but because we're SciShow, we took that a step further. We don't just tell you that an idea exists. We explain both how scientists use it and how it matters in the real world. Every kit sets you up to explore and demonstrate these concepts for yourself, and we made videos where I walk you through every single experiment. We're super excited about these kits, which can be found at a store near you or at universeunboxed.com.